Now that we've seen how we can encode primitive types as classes, the only two fundamental types of values that are left are instances of classes and functions. What we're going to look at in this session is how function types relate to classes and how function values relate to objects. In the last session, we've seen that Scala's numeric types and the Boolean type can conceptually be implemented like normal classes. But what about functions? Are functions special, or are they also just objects? In fact, function values are treated as objects in Scala, and not just conceptually, but in reality. What happens here is that the function type a arrow b is really just an abbreviation for the class Scala.function1ab, and that class is roughly defined as you can see here. In fact, function values are already treated as objects in Scala, not just conceptually, but really. The function type a arrow b is just an abbreviation for the class Scala.function1, two type parameters, the a and the b. And that class is roughly defined as follows. So it's a trait in package Scala. It takes the two type parameters a and b, and it has a single method which is called apply. So apply the function to an argument x of type a, yielding a result of type b. So functions are really objects with apply methods. What you've seen here was the definition for functions of a single argument, but there are also classes function2, function3, and so on, for functions that take more parameters. Currently we have those function traits until 22 parameters, but in the future there might be more, or we might be more flexible in that. Okay, so we've looked at function types. What about function values? Let's look at an anonymous function like the squaring function here, which takes an x and returns x times x. What would that expand to in this object-oriented view of functions? Well, it would be a new class that we create here called this anonFun. I assume that the name is not used otherwise in the program. And that would be a subclass of my function1 trait. Int are the argument types. And the apply method then would be one that takes an integer and returns the square of its argument. So that was the class that implements this behavior. Now all that's needed to do is create an instance of that class that would be the object that represents this function here. So creating an instance is simply new anonFun. In fact, that definition is again quite common, and there's a shorter syntax for it. It's called anonymous class syntax. So what we can do is we can take essentially this part here and leave out the name. So we write just new function1 int and the definition of that class. So that would create a new instance of a class that I haven't bothered to give a name. That anonymous class syntax you actually find in Java as well. So Java and Scala have the same syntax for this construct. Okay, so now we've seen how we represent functions. But what about then applications of these functions, or function calls? So let's say we have a function that started life as this anonymous function, so it's an object, and now we apply it to two concrete arguments, a and b. What would that expand to? Well, what it would expand to is simply calling the apply method of the function value with the same arguments. So a complete object-oriented translation of this code here, where we first create an anonymous function and then apply that function to the value 7, would be we create a anonymous class instance with an apply method, name it f, and then call the apply method of f with the argument 7. So now you see that functions are objects. Does the same hold for methods? For instance, this apply method here, would that by itself be an object? Well, that can't very well work, because if apply was an object, well, it would be an instance of this function class, which would have an apply method, which would be an object, which would be an instance of this function class, which would have an apply method. You see the problem. We would get an infinite expansion. So what happens instead is that methods such as def, f, Boolean, so anything that's defined with a def, are not themselves function values. But if the name of a method is used in a place where a function type is expected, it's converted automatically to the function value. And the conversion is just that we create an anonymous function like this one here, where we say, well, give me an argument, and I apply the method to the argument. That anonymous function value, we've seen how that expands to this new anonymous class, new function 1 int Boolean with the apply method. So that's how functions really are treated in Scala. A technical term which you don't need to remember, but I just give it for completeness here. So this transformation here that converts the name f to this anonymous function, it's called in lambda calculus eta expansion. So if you hear sometimes the word eta expansion, then you know now what it is. Let's do an exercise. In package week 4, where we have defined previously the list class with its subclasses, I want you to define an object list with some functions in it. And the idea would be that users will then create lists of length 0, 1, or 2, just with this syntax. So list of open parents, closed parents would be the empty list. List of 1 would be the list with a single element 1, and so on. So let's see how we would solve this. I've put up the list class that we've developed previously. So the task was to develop an object together with that class that would give us that syntax that we could just call list of 1, 2, let's say. So how would we do that? So the idea is, if we look at that syntax, list is used in function position. So what this would really expand to, we know that, would be list.apply 1, 2. So that means that we are asked to define a method called apply, and in that case it would take 2 arguments, let's call it x1 of type t and x2 of type t. So the t can be arbitrary, we have to parameterize apply with it. And it then would return a list, so the result type is list of t, and it would then return a list that consists of these elements, so that would be new of cons of x1 and new of cons of x2 and new of nil. And for the other two, for list of 1 and list of 0, the result would be analogous. So I leave out list with single elements, but for the empty list, I simply have an apply method. It takes no arguments and would give us new, nil,